Alright, ladies and gentlemen, today we are talking about operations with scientific notation. So you should feel pretty comfortable with scientific notation, going to and from normal numbers to scientific notation. Today we're going to focus on addition and subtraction. So before we start with scientific notation, I just got a few examples I want to go over. So if we have something like x plus x, you should be pretty comfortable to say that that is 2x. If we've got something like x squared plus x to the 5th power, that one's a little bit more tricky. I'm going to rewrite this in simplified form, so x times x plus x times x times x times x times x. Those you cannot add or subtract. In order to add or subtract anything with the same base, they also have to have that same exponent. So this one is not possible. 2x plus 3x, well, if you remember, multiplication is just repeated addition, so 2x is x plus x, 3x is x plus x plus x. So we got our first x plus x, and we also have another x plus x plus x. Repeated addition, we've got 5 of those, 5x. So when they have that same variable term, just the x right here, all you need to do is add those coefficients. 2 plus 3, those are the coefficients, 2 plus 3 equals 5x. But this next one, x cubed plus x cubed, so the coefficients aren't written there, but if they're not written, you can always assume that they're 1. So we've got one group of x cubed, which is x times x times x, and we're adding another group of x times x times x. So they've got the same exponent group right there. You can add the coefficients, 1 plus 1 equals 2, and keep that same term on there, x cubed. So 2x cubed would be the answer to this expression right there, simplified version. This last example, kind of bringing it all together, if you've got the same power right here, x to the 4th, x to the 4th, well, all you need to do is add those exponents together. So 7, and then we keep that power, x to the 4th power. So as long as the variables, they're like terms, all you need to do is add those coefficients, and you can get your simplified version right here, 7x to the 4th power. So the two important takeaways from this slide is that it is important to have the same exponent of your power. Otherwise, it's not a like term, you can't combine it. The other takeaway is once you do have like x right here, they're like terms, all you need to do is add those coefficients. So that brings us into our little notes for today, dealing with addition and subtraction. So with addition and subtraction, before numbers in scientific notation can be added or subtracted, the exponents have to be equal. Basically, all that means is you have to have like terms. So the exponents must be equal. Before numbers in scientific notation can be added or subtracted, the exponents must be equal. So if you look at this example we have right here, in this part, the exponents are not equal. 10 to the 2nd power is not the same as 10 to the 3rd power. Our goal is on this right-hand side, these are equal. 10 to the 3rd power, 10 to the 3rd power. Well, the nice thing about scientific notation, it's not a variable. Your base is not a variable like x or y. We know that the base right here is 10. So we can work with that. The key thing right here is that the decimal is moved to the left to increase the exponent. So 10 to the second power, in order to add these two together, we need to make it 10 to the third power somehow. Well, an exponent is just repeated multiplication, so let's multiply this by another 10 to get 10 to the third power. Well, if we want to keep this number the same, we have to move that decimal point to the left. So instead of 3.4, it's 0.34. So when adding and subtracting scientific notation, it's easier to get those power terms, 10 to the third power, to be the same as 10 to the third power. All you need to do, anytime you're increasing the exponent, you want to move the decimal place to the left. So anytime increasing that exponent, move that decimal place 1 to the left. Now we have our equal powers, 10 to the third. All you need to do is add those coefficients. So 0.34 plus 4.57 gives us our simplified answer of 4.91 times 10 to the third power. That's basically how we add add two numbers in scientific notation. Right here, if you feel comfortable, flip that sheet over. You can do those practice problems, but I do want to give you two examples that we can go over together right here. We got 4.3 times 10 to the fourth power plus 5.12 times 10 to the fifth power. So notice this first number, 10 to the fourth power. I want to increase that to be 10 to the fifth power. So anytime I'm increasing this exponent in scientific notation, I need to move this decimal point right here 1 unit to the left. So 4.3 becomes 0.43. Let me get that. Okay, so 0.43 times 10 to the fifth power now, because I moved that decimal point, plus 5.12 times 10 to the fifth power. We didn't change that one at all. So all I did, increase the exponent by 1, move that decimal point over to the left. Now we've got like terms. They're both times 10 to the fifth power. All we need to do, add those coefficients. So we've got 0.43, 0.43 plus 5.12. You can add those coefficients and you keep the power, so times 10 to the fifth power. So your final answer, 5.55 times 10 to the fifth power. There you have it. We increased the exponent, moved this decimal point 1 over to the left. Now we've got like terms. They both got that same power that they're being multiplied by. All we need to do, add those coefficients, and boom, 5.55 times 10 to the fifth power. Might be a good opportunity. Try this one on your own. Pause this video. Try this example on your own. See if you could subtract those two numbers using the same rules we just discussed. Once you start this video up again, I'll work through the solution with you, and then you'll have those few practice problems to do on the back. Alright, so hopefully you paused it. Try this one on your own. Let's see here. So we've got 10 to the sixth power and 10 to the fifth power. So I'm going to leave this first number by itself. 2.54 times 10 to the sixth. I do want to change this second one. I want to increase this power so that it's 10 to the sixth power, so we can combine these. So to increase that power, let's move this decimal point 1 over to the left. 0.32 and now it is times 10 to the 6th power. Increase the exponent, move that decimal point to the left. Easy enough. We've got like terms, times 10 to the 6th power. Let's add those coefficients. Well, in this case, we're subtracting, so 2.54 minus 0.32. And we keep times 10 to the 6th power. Alright, so we should be good to go. 2.54 minus 0.32 gives us 2.22. Interesting. Times 10 to the 6th power. Alright, so there we have it. 2 examples worked through. Key takeaway with these, make sure those exponents, those powers are the same, and then all you need to do, either add or subtract those coefficients. Should be easy enough. The last thing you do want to sometimes double check, scientific notation, make sure we only want one number on the left hand side of this decimal point. So you should have either a 1, a 2, a 3, all the way to a 9. Only one number, 15, no go. 0, no go. You want it to be a 1 through a 9. In this case, 5.55, that works out. 2.22 works out, so we should be good to go. Okay, so go ahead on the back side, do those practice problems, and hopefully you feel pretty comfortable with adding and subtracting numbers that are in scientific notation.